Look closely at this. It's a giant cylinder of almost perfectly pure silicon. Creating it took days. Engineers start with ordinary sand, then heat it to temperatures hotter than molten lava. Slowly, atom by atom, a single crystal begins to grow. The result is one of the purest objects ever manufactured by humans, worth hundreds of thousands of dollars. And in just a few seconds, we're about to cut it apart. Why? Because you can't build a computer on a giant silicon log. Modern computer chips need something much thinner, something almost impossibly flat. But that creates a problem. Silicon is incredibly hard, yet surprisingly brittle. Cut it the wrong way, and this entire crystal could shatter. So how do you slice one of the most precisely engineered objects on Earth without destroying it? You might think we'd use a giant laser or an industrial saw. But we use neither. Lasers can damage the crystal, and traditional saws create too much stress. Instead, we use a wire, an ultra-thin wire coated with microscopic diamonds. The wire moves at incredible speed, and rather than forcing its way through the crystal, it slowly grinds away tiny amounts of silicon, hour after hour, until the giant crystal becomes dozens of thin silver disks. These are called wafers. Problem solved? Not even close. If we zoom in, the surface looks terrible, covered in tiny scratches and imperfections. Trying to build a computer chip on this surface would be like painting a masterpiece on rough concrete. So the wafers go through another process: polishing, special chemicals, special pads, and extraordinary precision. Layer by layer, every imperfection is removed until the surface becomes almost unimaginably flat. In fact, if this wafer were scaled up to the size of the United States, the tallest bump anywhere on its surface would be only a couple of inches high. Now the silicon is pure. The surface is flat. Everything is ready. Right? Wrong. Because we're about to meet one of the biggest enemies in semiconductor manufacturing: dust. Not a power outage, not a machine failure. Dust. The electronic switches we're going to build on this wafer are unbelievably small. A human hair is roughly 10,000 times wider than many of their features. At that scale, a tiny speck of household dust isn't tiny at all. It's an asteroid. One particle can ruin an entire chip, which is why wafers are moved into facilities called clean rooms. The air is filtered so aggressively that almost no particles are allowed to exist inside. Engineers wear full-body protective suits because even a single skin cell can contaminate the process. Only in an environment this clean can modern computer chips be built. We finally have our perfect silicon canvas, but now comes the hardest part. How do you draw patterns thousands of times smaller than a human hair? You don't use a pen. You use light. Extreme ultraviolet light. And that's where the real magic begins. In the next episode, we'll explore photolithography, the astonishing process that allows engineers to print entire cities of transistors onto a single wafer. Thanks for watching.